Hello everyone, welcome to CSE Core Concepts in my series of machine learning algorithms with implementation in RStudio. Now in my last video I had discussed about association rule mining algorithm, that is the a priori algorithm, and we have discussed that it is majorly used in retail sectors to find out the association among the products, either in retail, in service industry, product industry, and the application goes on. Now in this video, I am going to demonstrate how can you apply the a priori algorithm in using RStudio, and then we will discuss the results which we will get from them. Now, before starting on with the coding part, I would like to briefly discuss about RStudio. So you can download RStudio for free for Windows version from its official website R, and sometimes it does require a prerequisite of installing R before RStudio. So that can be automatically done from the website and it is free of cost. And once you download R and you open the application, the screen looks something like this. Now here, let's say for example, you are going to start with a new data, so new file. So here you can click on R script. Now you can see below there is a console. Console is somewhere the codes will be executed. But if you are directly writing the codes on the console, then it may not be saved. The files may not be saved. So in that case, we are going to write the commands in the commands in the script area, which we can save, and from here we can express the run button so that the commands will be executed in the console. Thereafter, you can see on the right hand side there is a small window here which is saying environment. Environment will give us all the details about the data frames or the variables which will be created and what values they will have. And there are history also, you can get what you have already done, connections, tutorials if you require some help. Okay, so we will keep it in environment mode. And just below the environment mode, you can see another small window, a section where you can see it has the plots tab is on. That is, when you want to visualize any data like with graphs, that can be visualized in this section. Files are there, what files you have already stored. Okay, they will be shown. You can directly open the files from here. You can see the graphs from the plots tab, and packages you can see. You require certain library files like in C, Java. We require some library files, right, in Python. So here also you require some library files. So that if it is, you can check here if it is already installed, then there will be a tick mark. Otherwise, you can install from here directly. Help is there, viewer, presentation, everything. So we will be keeping this on plots. Now to get started with, of course, we have to first read a file. We have to get the data on which we can apply the a priori algorithm. Now I will show you some example data sets. This is a sample data set of cosmetics where you can download such data sets. You can get from GitHub or Kaggle. So you can just search them. So this is something which I got from Kaggle, that is a cosmetics data set. Now here you can see there are 14 items which are there in the store. Bag, blush, nail polish, brushes, concealer, eyebrows, so on till eyeliner. And from the record number 2, you can see the transaction starts. So the first customer purchased a blush, nail polish, brushes, concealer, bronzer, lip liner, mascara and eyeliner. The second customer bought nail polish, concealer, bronzer, lip liner, foundation and lip gloss and so on. So this way I have around 1000 records over here. Okay, so I am going to apply a priori algorithm on such data. Now if you wish, you can create your own data set also. Let's say in the previous video we discussed an example, a very small example having only 5 transactions. So this way also you can create for practicing first, and then you can go for higher data sets. So we had 6 items, if you remember: bread, cheese, eggs, juice, milk and yogurt. And the first transaction, the customer purchased bread, cheese, eggs, juice, and so on. Okay. So this way you can create your own data set, or some other data sets also you can get from Kaggle, like retail data set, where it is written directly, the names of the products are written which has been brought, like bread, wine, eggs, meat, cheese, pencil, diaper in the first transaction, and so on. So these are some of the sample data sets. So for this video, I am going to refer to the cosmetics dataset. And remember, these datasets are in the CSV format, that is comma separated values format. So let us go back to our RStudio R script. And before starting, we have to include the library files. So the library which is being required here is A-rules. A-rules contains the files, it supports the Apriori algorithm. So after you write on the script bar, you can just press the run button and it will be executed in the console. Now I have to read my data first of all, right? I have to see my data. I have to import it, right? So let me take one data frame. Here we don't call it as an array, we call it as a data frame. So my data is equals to read dot. So my file is a what format? CSV format. And then the path of the file you are going to write. Let's say my path is this, cosmetics.csv. So this will be included. Yes. So my data has been read. Now in case if you want to see your data, how can you see your data? First of all, have a look on the right hand side on the smaller window on the environment section. You can see my data named data frame has been created, which is having 100 observations of 14 variables. You remember we had 100 rows and there were 14 items, right? 14 variables. So from here you can see whether your variables are created or not, and they are being assigned proper values or not. Now if you want to have a look at your data, you can see on the right side a small square shaped object is there. You can click on it. So when you click on it, your data will be opened. So this is what we have seen in the CSV file, right? So this again you can just have a look here. So I will close it for now. And then if you want to see the structure of your data, you will write str my data. So you can see the variables and the types of data types of the variables. So you can see in console, you wrote data frame having 1000 observations of 14 variables. First variable is bag. It is of type character and the values are in form of no, yes. Second variable is blush, which is again of type character and the values are of yes, no, right? So this way all 14 variables are being kept, right? Now let me apply the Apriori algorithm on this data. So I will declare one variable rules, okay, is equals to Apriori. This is the name of the function in the library A-rules, and simply I will pass my data frame, that is my data. So if you run, you can see something is occurring here. Now if you remember, in my video I told you that Apriori requires some sort of minimum support and confidence. But if you observe here, I have not mentioned anything, support, what value, confidence, nothing, lift, nothing I have mentioned. So what will it take by default? So if you read on this, you will see parameter specification, confidence is 0.8. That is by default it takes 80% confidence, and by default it takes a support of 0.1. That is 10%. Then it is creating some rules of length minimum 1. Now one length means what? Only one object rule. Means nail polish is a rule, brush is a rule, foundation is a rule. That is the minimum value it is taking. That every object individually they are becoming rules, and maximum length of the rules is being taken as 10. So 10 items clubbed together make a rule. So let us see how many rules have been formed with such a values. So if you want to see, we'll just write rules. I want to see. So 68,880 rules are found. So you can imagine it is very much possible. Why it is possible? Because every product itself first became rule. Combination of two products became rule. Now whether they purchased or not purchased, it became a rule. Okay, no foundation is equals to no concealer is also a rule. No hairbrush is equal to no nail polish is also a rule, because still we have not filtered anything. Okay, whether you want the rules of yes or you want the rules of no. So everything they have made a rule, right? Then if you want to see a summary of rules, so you can write here, sorry, I am writing in the console. You can directly write in the console also. That is not a problem, but that will not be saved. Okay. So you write in the script summary, sorry, summary of the rules. Yeah, summary. Yes. So I can see the summary of my rules. So summary of the rules is the minimum support is 10%. So the products are starting from minimum support of 10%. 10% means if you are counting 1,000 transactions, so 10% of the transactions are also considered as the rule. Maximum it is support is going up to 95%. Then confidence is minimum 80%, because I told you that is a default value. Maximum confidence is going up to 100%. Minimum lift measure is going by 0.8, that is 87%. And maximum is going beyond this. Count, this is what is given, median count, mean count, that is the number of times the product is appearing. So minimum 100 times the products are appearing, not less than that, and maximum 958 times any products are appearing, right? So if you want to inspect the rules, now I am very scared of writing this, because inspection of the rules will give me the details of all rules. Now you imagine we will have around 68,800 rules. Let me just run it, and yeah, so you can see we reach to 31, and these are the numbers, these are the rules which are getting created. The support and the confidence and the lift values are also been given here. Understood? So it is going on, because how long will it go on? It will go on till 68,850. So I'm stopping it in between just to show you that you can see brushes no, concealer no. This is any random rule I am just showing you. Eyebrow pencil no, eyeshadow no, lipstick yes, means lip liner no. So is this rule meaningful, do you think? No. You just want to know the rules which are meaningful. Meaningful in the sense what the customer purchased. Which combination of the product was purchased more. One product sold, because of which product. This is what you are interested in. Understood? So obviously this is not a very good form of rule. Now let us do one thing. Let us first refine the rules. We do not want the default support and confidence. So let us put some regulation on the support and confidence, so that we can reduce some rules. So a priori my data parameter is equals to list. So what are we going to list? We are saying our requirement is that minimum length of the rule should be 2, right? At least 2 products should make a rule, and max length not more than 3, right? That only 3 product rules we want, not up to 10. By default it was going to 10. Then I require a support of, let's say 0.5, that is 50% support, and confidence is equals to, let's say 0.8, that is 80% confidence. Now let us analyze this. Okay, so what happened here? Confidence is 80%, as I wrote. Then support is 50%. This is our criteria. Minimum length 2, maximum length 3. So let's see how many rules are being created with this condition. So 131 rules are being created. Understood? 131 rules are created. Now you can inspect these rules. Inspect rules. See, still the no condition rules are coming. They have not eliminated. That I will show you how to eliminate. So these are some of the rules which are being created. So what are the rules? You can see any random rule. Nail polish, no. Brush, no. Bag, no. So do you feel that it is a meaningful rule? Nothing has been purchased. So what? Okay, it is not at all a meaningful rule. So if we are interested only to find some of the interesting rules, right? See, if you want to write something in the comments, you can use this hash symbol here. So we will write finding interesting rules. Okay, so let's see how to find out interesting rules. I will write rules is equals to a priori, my data, then parameter is equals to list. Let's say minimum length is same, that is 2. Maximum length is 3. Fine, we want to restrict it. Support is equals to, let's say, same, 0.5. Confidence is equals to 0.8. Understood? This up to this is clear for you. Now, what type of appearance do I want? I want appearance because I want to restrict on the no rules, right? So I am saying list RHS right hand side is equals to C. I am saying I want the rules only for foundation. Okay, let's say you can make for more also, no problem here. Foundation is equals to yes. Okay, and then you will write comma default. Left hand side you are saying anything, that's okay. Left hand side does not matter, but you want only the rules for which the foundation is yes. Okay, let's see. Yeah, let's see. Yeah, I got some rules. That is 80% confidence, support 50%, mean length this, max length. So let us see how many rules we got here. Let's say, sorry. Let us write down rules. 0 rules. I didn't get any rule at all. Okay, this might be possible because I can reduce the confidence. Let's say because of confidence, maybe the rule is not being created. So let's say I'm making rule of 0.5 confidence. Let's now see how many rules are found. Yes, at least I got 2 rules of this same criteria, right? So let us inspect the rules. Inspect rules. So bag no, foundation yes. Eyebrow pencil no, foundation yes. So that means what? At least we know one thing, that people, those who are buying foundation, are at least not at all buying bag and eyebrow pencil, right? You can see the support is 50%. Okay. The confidence is 53%. Fine. The lift is 0.99, less than 1. So not very strongly related. And here it is 1, means they are not related at all. There is no relation between eyebrow pencil and foundation. How much count? Means 505 times this combination is appearing. 517 times this combination is appearing. Let us see some more rules so that we can get. Let us reduce this support by 0.3. Make it 30% so that we can get some more rules. So 44 rules if I am reducing. So this way you can work, right? You can do testing, trial and error using this changes in the rules. So now I got at least 44 rules. Okay, so 44 rules says lip gloss yes, foundation yes. So that means people are buying foundation and lip gloss together. Support is 35%, confidence is 72%, lift is 1.3, very highly correlated. Understood? Concealer no, foundation yes, that's okay. Like this. Still I am getting the no, but because I have kept the restriction only on the foundation yes, right? I can keep some other on the left hand side also. Let's say for example I can write rules is equals to a priori, my data parameter is equals to list, minimum length is equals to 2, max length is equals to 3. Okay, same support I am keeping. Support is equals to 0.3. Confidence is equals to 0.5. Okay, now I will write on the appearance. I am focusing on the appearance. So my appearance this time says that list, okay, so RHS is equals to C uh, foundation is equals to yes, right. Now I want to keep little bit of restriction on the left hand side also. So LHS is equals to C, then you can say bag is equals to yes, and you can even keep more restrictions like blush is equals to yes. Okay, so this way also we can keep. Let's say for example, let's execute this one and see if we can get some meaningful rules or not. Yes, I got some rules. Let us say how many rules we got here. So we got no rules, zero rules we got because we have kept this condition. Okay, sometimes if you can relax also here, like you can say, yeah, so you can say here default is equals to LHS, right? So if you are keeping like this, yeah, so yes, let's see the number of rules I am getting here. 44 rules I am getting. So let's inspect the rules. Yeah, so you can see here foundation is yes, right hand side is same for all. Okay, then you can say bag no, eyebrow pencil no, blush no, because I have set it default. Similarly, you can keep it otherwise also, right? You can keep this as the other variable. Okay, and you can keep multiple also. Like only foundation, yes, no. If you want to make a value rule, then also you can set it. Understood? So this is how you can create it. Now, if you want to see the quality of the rules, I'm not sure about this. Okay, so whether you will always get it or not, because it also depends on the type of data or the rules which are being created. Okay, so quality rules digits 3. Okay, let's see the inspect. Fine. So again you got around 44 and this is up to the 3 digits lift value. You can see here the lift value was going very high, right? After decimal point, but now you have made it to up to 3 decimal digits. You can make it to up to 2 decimal digits. Understood everyone? Even the support, confidence, everything. See here it was more. The confidence is going for more decimal places. You can restrict so that it is understandable, right? You do not want very big decimal values. Understood? Now, if you want to sort out the rules, then also it is possible. Rules dot sorted. Okay, so you may even sort the rules, let's say by uh, lift. Okay, so let me see the rules set of this. So the rules are being sorted. Okay, so not exactly, I cannot see them, so fine. Summary of the rules, you can just see the inspect rules, right? And then you can summary and all. Now you sometimes we can see that some redundant rules are occurring. Redundant. So if you want to see the redundant rules, right? Is dot redundant. Okay. So you can say rules measure based on confidence, right? You want to see the rules which are redundant based on confidence. 1 minute, confidence. Okay, so you can see here. So let's see which rules are redundant. So you will write which redundant. Which rules are redundant? Yes. So rule number 15, 16, 17, 18, they are becoming redundant, right? So 15, that is no bag, yes, lip gloss, foundation, yes, that is redundant, means it might be occurring 2 times. Understood? So these are your redundant rules. Then if you want to prune it, you can prune it, that you want to find out the rules dot pruned, rules which are not, sorry, redundant. Okay, so let's see the rules. Set of 44 rules, right? So this way you can see the a priori algorithm in various ways. Now let's see if I want to plot them. Understood? If I want to plot them, then the library file which I want to include is a rules viz, that is visualization. Understood? So I will simply plot rules. So let's see on the right hand side. I have shown you, you can zoom here. There is a button for zooming. Sorry. So you can just zoom the plot. Yeah. So you can see this plot. Now this is not very much readable because this is a support versus confidence plot and it is based on the lift value. You can see here on the right hand side the measures are given lift value greater than 1. Okay, which are the stronger relationships. They have not shown the weaker relationship. Now slightly the orange color is getting darkened. The weaker relationships are in lighter shades and the stronger ones are going the dots. Okay, let's see some other ways if we can find out. So I can say group. Let me group it. Plot rules, comma, grouped. Okay, let us see and understand it better way. So you can see, zoom it over here and see. Just a minute. Yeah, so we can see, zoom it and see. So you can see here support values are given. So first rule is lip gloss yes, lip liner no. Foundation is yes. Okay, right hand side was our same. Okay, so lip gloss yes, lip liner no. Then second, next rule is lip gloss yes, brush is no. So these are the stronger relations. Now as it is going on the right hand side, you can see eyeshadow no. So if foundation is yes, eyeshadow is no. If foundation is yes, eyeshadow is no, eyebrow pencil is also no. So there is no major relationship between foundation and eye makeup, right? This is what is being shown. So it is going on fading towards it. Understood? So this is how we can implement. So you can try on your own using various functions, or you can try with various support and confidence values. You can try with separate conditions. Okay, like you can try on your grocery sets, data sets. Fine. So I hope you understand this implementation, and I do suggest you to try it. So in the next video, I'm going to start with the KNN algorithm, that is K nearest neighbor. So don't forget to like, share and subscribe to CSE Core Concepts for timely notification of the updated videos. Thank you.